Have you ever wondered why the ground beneath our feet, often so solid and reliable, suddenly shakes and shatters, causing widespread chaos? Earthquakes, a natural phenomenon as old as the Earth itself, are responsible for this. But what exactly causes these devastating seismic events? Earthquakes occur when there's a sudden release of energy in the Earth's lithosphere, the rigid outer shell comprising the crust and upper mantle. This release of energy creates seismic waves that make the ground shake, often with catastrophic effects. But to understand why this energy release occurs, we need to delve a little deeper into the Earth's structure. Picture the Earth as a giant jigsaw puzzle made up of a series of interlocking pieces called tectonic plates. These plates don't just sit still, they're constantly moving, albeit at a pace slower than a snail's race. They slide past each other, collide or pull apart, driven by the intense heat and pressure from the Earth's interior. Most earthquakes occur along the boundaries of these tectonic plates, in regions known as fault lines. When plates try to move but get stuck at their edges due to friction, stress builds up. Eventually, when the stress becomes too much, the rocks slip, releasing the stored energy as an earthquake. Now, how do scientists measure the power of earthquakes? They use a tool called the Richter Scale, named after the American seismologist Charles F. Richter. The Richter Scale quantifies the energy released by an earthquake, with each unit representing a tenfold increase in seismic energy. For instance, a 5 on the Richter scale releases 10 times more energy than a 4. Earthquakes can have profound impacts on the Earth's surface, ecosystems, and human infrastructure. They can trigger landslides, cause buildings to collapse, and even change the course of rivers. But their effects aren't just limited to the immediate vicinity of the epicenter. Seismic waves can travel great distances, causing destruction far from the earthquake's origin. Understanding earthquakes and their impacts is crucial, not just for scientists, but for everyone. Preparedness can save lives when the next big quake strikes. This includes knowing what to do during an earthquake, such as dropping to the ground, taking cover under a sturdy piece of furniture, and holding on until the shaking stops, and having a disaster plan in place. In conclusion, earthquakes are a powerful testament to the dynamic nature of our planet. They remind us that the earth beneath our feet is alive and constantly changing. By understanding the science behind earthquakes, we can better prepare for these natural events and navigate them with resilience and understanding. So the next time the ground shakes, remember, it's not just a quake, it's the earth telling its own dynamic story.